All right, algebra students, we are in our equations unit, so we're still in unit 2, and today we're going to be looking at solving equations. With either one infinite or no solutions. And I can't remember what page number this is on. I think we're on page 10. Yeah, page 10 in your notebook. All right, so of course up until now, in your learning of mathematics, you have been solving equations that have one solution. You've been getting x is equal to 5, x is equal to 7, x is equal to negative 10, x is equal to 0.5. You've been getting one solution. So today we are adding, what does it mean to have infinite solutions? So what does it mean for every single number in the entire universe to be an answer to the problem? Or what does it mean if there is no number that would work? What happens when there is no solution? And so we're going to be looking at these three categories today. And so it would be, I was going to say let's split our paper into 3 equal sections, but let's just go ahead and start with the first one, and then we may actually have to go on to the back of page 10, onto page 11. We'll see. All right, so let's start with, what does it mean to have one solution? So, of course, one solution means that only one value will make the equation true. And again, this is what you have been working on for the majority of your mathematical career. Only one value will make the equation true. And so let's look at an example of what this would look like. So for example, maybe we see an equation that looks like this. So 2 and then 4x plus 5 is equal to 2x plus 4. All right, and so we want to solve this, and so we start thinking about the DCBA method, and so we start with distributing. So we're going to distribute first. This is what we learned in our last video. So distribute here, we're going to get 2 times 4x is 8x. 2 times positive 5 is positive 10 is equal to, we're going to distribute the 5. So 5 times 2 is 10x. And then 5 times positive 4 is 20. So we've done distributing. We can look on either side. Are there any like terms to combine on this side? 8x plus 10. No, that has an x, that's a number. So no like terms on this side. Also checking on this side, 10x is not a similar term to 20. This has an x, this does not. So no combining like terms. B stands for bring the variables to one side, so we can either subtract 8x and move it over here, or we can subtract 10x and move it over here. I tend to like to avoid negatives, so I'm going to take the smaller number away. So I'm going to subtract 8x from each side, subtract it from the x over here. On this side, we're left with 10 is equal to, and 10x minus 8x, again, if you still draw the line down the middle, that's what this would look like. 10x minus 8x on this side gives me 2x, and then I bring down my plus 20, subtract 20 from each side, that's going to cancel. On this side we're left with 2x, and on this side we get negative 10. Last step is to divide by 2, and we get x is equal to negative 5. Oh, we're definitely going to have to go on to the next page for notes, so just remember, we're going to keep page 11 open because we're going to have to do some examples on that side. All right, so again, you get one solution, right? The answer to this problem is negative 5. And what that means is that only negative 5 will solve this equation. One solution. This is what we call one solution. It's the only solution that will work. Now, I'm gonna put a star right here because we're gonna come back and add a little note about how we can know that something has one solution. So go ahead and put your little star there, and we're gonna leave a couple of lines for us to write in a reminder, and we're gonna come back to that, okay? So leave a couple of lines, leave about 2 lines, draw yourself a line all the way across. And now we're going to look at what does it mean to have infinite solutions. So what do I mean if something has infinite solutions? So we're going to write that down. So the next section is infinite. And here's what this means. This means that any value will make this equation true. If you think to the assignment that you previously finished, the assignment that you finished before this, these were those boxes where you could have drug any number into them, right? And they would have still balanced. So any value will make this equation true. So for example, let's look at a problem like this. So let's look at 5, and then in parentheses, x plus 3 is equal to 5x plus 15. All right. And so I don't know in the beginning whether it has one solution or infinite solutions. So I'm just going to, again, start solving like I know, D, C, B, A. I'm just going to start with those normal steps. So distribute still comes first. We're going to distribute the 5. So we get 5x. And then 5 is going to get distributed to the 3. That's 15 is equal to 5x plus 15. Now, notice something really odd here. This is the same thing as this, right? Like both of these sides are equal. And if we continue with our steps here, we've done distributing. There's nothing to combine on this side. There's nothing to combine on this side. They're not like terms, so the c's gone. I'm ready to bring the variables to one side. Watch what's going to happen. If I try to bring, let's say, I'm going to, hey, get rid of this 5x. It's canceled. If I subtract 5x on this side, what happens? Well, 5x minus 5x also cancels. And so what am I left with? I'm left with 15 equals 15. Now, my x's are gone, right? I canceled out my x's, and I get this statement that 15 is equal to 15. Well, when is 15 equal to 15? Always. 15 is always equal to 15. And even if I were to go back to this step right here, where I see 15x, not 15x, just 5x. If I see 5x plus 15 is equal to 5x plus 15, what numbers could I plug in for x? Like, what if I plugged in a 1? What if I said, hey, let x be 1? Well, that's going to be 5 times 1 plus 15, and that's going to be 5 times 1 plus 15. That's 5 plus 15 is equal to 5 plus 15, and that's 20 is equal to 20. When is 20 equal to 20? That's always true. What if I had instead plugged in 2 each here? Well, instead of this being a 5, that would have turned this into a 10, and that would have meant that 25 is equal to 25. I could plug in any number I wanted to because these are the same equations on both sides. 5x plus 15 is the same thing as 5x plus 15, so it does not matter what my x value is. They're always going to be equal to each other. This is what we call infinite solutions. Don't ask me why I capitalized the word solution and not the word infinite. This is what I would call an infinite solution. When you get two things that are equal to each other on both sides, what this means is that any value works for x. Any value works for x. And again, we're going to come back to this and write a little reminder, so put you a star right there. But that is what it means when we're dealing with infinite solutions. We get the same thing on both sides of the equal sign, which means that I could plug in any number for x. All values work. I could plug in 100 and x would work. It would create two equal things. So this is what we mean by infinite solutions. Now, flip it over to the next, so page 11. And we're going to write down, what does it mean then to have no solution? What does it mean to have no solution? So this means that there are no values which will make the equation true. Nothing will work. So for example, let's do 2 times 2x in parentheses plus 4 in parentheses is equal to 4x plus 3. And so I'd start solving it always the same way. I'm always going to use DCBA to start solving because it's an equation. I'm going to solve it that way. So distribute if you can. I'm going to distribute first. 2 times 2 is 4x plus 2 times 4, which is 8, is equal to 4x plus 3. Now we end up in a similar situation here because we have distributed combined like terms. 4x plus 8 is not like terms. 4x plus 3 is not like terms. So when we get to this bring the variable to one side step, we end up, like I said, in a similar situation. If I try to bring the 4x to the other side, what's going to happen over here? Well, 4x minus 4x cancels, and 4x minus 4x cancels on this side as well. My x's cancel out, and I get this answer of 8 is equal to 3. Now, the reason this is different than what we got on the infinite solution is that on the infinite solution, we had 15 is equal to 15, and that's always true. But when is 8 equal to 3? That is never true. And so this, when we come up with something that is never going to be true, we know that this means that no solution is possible. No solution. No, there is no number that will make this true. And even, again, we could go back to this step right here and probably observe that. When we knew that 4x plus 8 was equal to 4x plus 3, what could I plug in that would possibly make this work? Because this part is always going to be equal to this part. If I plug in 2, that's going to be 8, that's going to be 8. But 8 plus 8 is never going to be the same thing as 8 plus 3. This is like, if you did the assignment before this is like those balances where you always had something extra that was never going to actually balance out. So this is what we see when we have no solution. Now, I want to go back and fill in these stars for the reminders of how are we going to know, or how are we going to recognize when we come across a solution like this. So for one solution, I want you to notice after we distributed, when we got to our part where we were bringing the variables to one side, I want you to notice something about the coefficients here. One side had an 8x, one side had a 10x. When you get to a point in a problem where it's going to be one solution, what you're going to notice is that the coefficients on the variable, so remember, coefficient is just that number in front of the variable. The coefficient on the variable is going to be different. This is 8 and 10, right? And 8 and 10 are different coefficients on the variable, so they're different. That's one way that you're going to be able to notice that this is going to be one solution. Now, down here for infinite solutions, what do we notice about the coefficients in front of the x right here? They were the same, right? So when we're dealing with infinite solution, we're going to end up with the same coefficients on the variable. But we're also going to notice that not only are the coefficients the same, but actually the whole expression on each side, right, is going to be equal. So when we find the same coefficients and both sides are equal, both sides become equal, like they're exactly the same, then we know that we're going to have infinite solutions. So that's the reminder of this is how you know you have infinite solution. Lastly, for no solution, notice we find that we have the same coefficient, right? We had the same coefficient here. So same coefficient on the variable. But of course, the difference here, oh, my screen froze. Same coefficient on the variable, they were both 4s. But of course, the sides are not equal. One side we had an 8, one side we had a 3. So sides not equal. All right. So just to make sure we're solidified on this, we're gonna, page 11, we're gonna go ahead and draw you a line all the way across that again. And I'm going to give you 3 examples for you to pause and work on your own and tell me whether it's going to be one solution, whether it's going to be infinite solutions, or whether it's going to be no solution. So the first problem, again, you can pause the video and try these on your own. First solution, first number is going to be 4x plus 6 is equal to 18. So solve that one. The second one is going to be 2 times 5x plus 4 minus 11 is equal to 4x plus 3 times 2x plus 1. That took up a lot of space there. And I'm going to go down below here. So example number 3 for you to try on your own is going to be 3, 5x plus 6 is equal to 7 times 2x plus 1. And that last part is going to be plus x. Yep. All right, so go ahead and pause the video. See if you can figure out which one is one solution, which one is no solutions, which one is infinite solutions, and then I will come back and we'll check. All right, so for the first problem, I have already worked that one out for you, and so again, hopefully you have paused the video and worked this out. For the first problem, it's pretty straightforward. Subtract 6, divide by 4, you end up with x is equal to 3. So this is what we would call one solution. Now, on the next couple of problems, we're really deciding which one of these is no solution, and one of them is, of course, going to be infinite solution. So for this one, we will distribute first. That's going to be 10x plus 8. Just check your work along with mine. Is equal to, and of course we have to distribute over here as well, plus 6x plus 3. We can combine some like terms here, so we can combine the 8 minus 11. So this one is going to give us 10x, and then we've got 8 minus 11, which is going to give us minus 3, is equal to, on this side we can combine the x's. There's 4x's plus 6x's, 10x's plus 3. Now, right here you should be getting an indication. My coefficients are the same. Are these numbers the same? Well, no, this is negative 3, this is positive 3. And so when I go to cross these things out, when I go to move my variables to one side, they both cancel and I'm left with negative 3 is equal to 3. Is negative 3, don't lose that negative there, is negative 3 ever equal to positive 3? This is no solution. That is never the case. These things are not equal right here. This is 10x minus 3, this is 10x plus 3, no solution. Which means that this last one should be your infinite solution. And of course I'm going to distribute everything first. That gives me 15x plus 18 is equal to 14x plus 7 plus x. Nothing to combine over here. 14 and 1x gives me 15x plus 7 on this side. And I get 15x plus 18. I thought I had came up with a infinite solution, but apparently not. Well, you have probably already figured out then that this is also no solution, because when I subtract 15x, those both cancel, but I end up with 18 is equal to 7. So guess what? This is also no solution. Well, we were expecting it to be infinite solution, but guess what? It wasn't. If this had been 18 is equal to 18, of course, it would be infinite solution. If these numbers had came out to be the same, it would be infinite solution. So make sure that you pay attention to that on your practice. And when they come out to be two different solutions, make sure that you pick no solution. If they do end up being the same, that's when you're going to get infinite solution. Good luck on your practice.